Welcome to The Explainer. Today, we're diving straight into one of the most fascinating engineering marvels of the 20th century, the Mikoyan-Gurevich MiG-21. Now, if you follow military aviation, you absolutely already know the silhouette, but we are going to promise you a fascinating deconstruction of the most ubiquitous supersonic fighter in human history. We're talking about a jet drafted up in the 1950s that went on to become the ultimate Cold War icon. It literally outlasted the very engineers who drew its blueprints, and even the empire that funded its creation. We're going to look at the anatomy, the incredibly rapid evolution, and the real-world legacy of this absolute machine.
All right, let's kick things off with a completely staggering number, 11,496. That right there is the Guinness World Record for the most produced supersonic jet fighter in history. Built over several decades from the late 50s well into the 80s, the sheer volume of MiG-21s pushed out into the world is just mind-boggling. To really put that scale into perspective for us today, a highly advanced fifth-generation fighter, like the F-22 Raptor, that saw a production run of less than 200 units. Even the massive F-35 program is only aiming for a few thousand over its entire lifespan, but almost 12,000 fish beds rolled off those assembly lines. So what drove that kind of massive output? Well, the philosophy is perfectly summarized by this quote from the Indian Air Force. A simple shape, a legendary fighter. And that really sets the stage for everything we're exploring today. This wasn't about over-engineering. It was a bare-bones, pragmatic tactical philosophy. For the pilot, this meant stepping into a cramped cockpit packed with analog dials. It meant relying on raw, brute force instead of fly-by-wire computers. It was a rugged, unapologetic machine built to do exactly one thing very well. And that focused simplicity is what allowed it to spread like wildfire and literally conquer the globe.
Which brings us to the core question of our explainer. How did one single fighter jet conquer the globe? How does one base design become the absolute backbone for so many different air forces, operating everywhere from the humid, sticky jungles of Southeast Asia to the scorching deserts of the Middle East, across decades of conflicts? A big part of the answer is that the global production footprint was just a logistical marvel. Obviously, the Soviet Union did the heavy lifting, churning out 10,645 aircraft from three major factories in Moscow, Gorky, and Tbilisi. But that massive output was strategically supplemented by licensed production around the world. You had 657 units assembled over in India by Hindustan Aeronautics Limited, and another 194 models built in Czechoslovakia by Aero Vodafone. This kind of distributed industrial effort made sure the aircraft wasn't just a Soviet weapon. It became a global commodity, cementing its proliferation everywhere. Section 1. Anatomy of the fish bed. To really understand this aircraft, we have to get into the philosophy of its creators. The Mikoyan-Gurevich Bureau, founded back in 1939 by Artem Mikoyan and Mikhail Gurevich, had a highly specific mission during the Cold War. They explicitly prioritized rugged construction and mass production over complex, fragile technology. The era demanded a lightweight interceptor that could be built fast. Just look at the core design principles: a fast interceptor, simple maintenance, highly affordable, and totally adaptable for mass production. That simple maintenance part? Absolutely crucial. Soviet client states and allied nations didn't always have pristine, paved runways or highly trained aviation mechanics. They needed a jet that could operate out of really austere environments and be serviced with basic tools.
But simple absolutely did not mean slow. We're talking a maximum speed of Mach 2.05 at altitude, an initial climb rate of 58,000 feet per minute, a service ceiling pushing right up to 57,400 feet. The tactical implications of those numbers were huge. During the Cold War, the main threat was high-altitude strategic bombers, like the American B-52, or reconnaissance aircraft like the U-2. Air defense networks desperately needed an interceptor that could scramble from a runway and just rocket up to 50,000 feet in minutes before those bombers could drop their payloads. The MiG-21 was essentially a manned missile, built purely to counter that exact threat profile.
And driving those incredible stats was a single Tumansky R-25-300 turbojet engine. This power plant cranked out an incredible 15,535 pounds of afterburning thrust. For the pilot, hitting that afterburner gave a visceral kick in the back, launching the lightweight airframe forward with just staggering kinetic energy. Now, early turbojets were massive gas guzzlers, right? So the MiG-21 had notoriously short legs. Often it only held enough fuel for a rapid, lightning-fast interception and an immediate return to base. But when you pair that explosive thrust with a simple, reliable 23mm cannon and K-13 air-to-air missiles, you had a highly lethal point defense package.
Moving to Section 2, from prototypes to perfection. So how exactly did they nail this iconic design? Let's look at the Generation Zero prototypes. Notice the incredibly frantic pace of iteration by the Soviet engineers between 1954 and 1956. In 1954, they have the Yi-1 and Yi-2. By 1955, they're already testing the Yi-2A and the Yi-4. And by 1956, they are flying the Yi-5 and the experimental rocket-boosted Yi-50. This was a period of intense, immense pressure. The Cold War arms race was accelerating rapidly, and the demand to push out iterations resulted in a grueling, nonstop pace of trial, error, and aerodynamic refinement. Ultimately, the engineering evolution of all that frantic iteration came down to wing geometry. The early Ye-2 used a traditional swept-wing design, but the engineers quickly pivoted to the final, iconic delta wing for the Ye-4 and Ye-5. The physics behind this change are actually really fascinating. At supersonic speeds, aircraft encounter massive wave drag. A delta wing minimizes this wave drag beautifully, allowing the jet to punch straight through the sound barrier with way less resistance. Now, this definitely came with a severe trade-off. Delta wings are notoriously poor at low-speed maneuverability, and they demand frighteningly high landing speeds. But for an aircraft specifically designed to fly straight up at Mach 2, it was the perfect aerodynamic compromise. Section 3. Global Reach and Combat. Okay, let's take the jet out of the factory and into the real world. The MiG-21 was deployed by roughly 50 to 60 air forces across 4 different continents, from Eastern Europe and Asia all the way to Africa and the Middle East. Its sheer simplicity made it the absolute perfect export. For a ton of pilots outside the major world powers, the MiG-21 was their very first time flying a supersonic aircraft. It fundamentally shaped air combat doctrine in the developing world, serving as a real baptism of fire in heavily contested skies. From Operation Rolling Thunder over the jungles of Vietnam to the massive aerial engagements of the Six-Day and Yom Kippur Wars, the fishbed was just everywhere. To truly understand its combat longevity, though, let's look at one specific engagement. August 10, 1999, the Corey Creek Intercept. The geopolitical stage here was incredibly tense. This took place just weeks after the conclusion of the Kargil conflict between India and Pakistan, so border anxieties were at an absolute peak. An Indian Air Force MiG-21 intercepted a Pakistan Navy Atlantic patrol aircraft that, according to the sources, had entered Indian airspace. The sources detail that the engagement concluded when the intruding aircraft made an aggressive turn toward the interceptor, and the MiG-21 immediately engaged and downed the aircraft. The sheer irony of this is incredible. By 1999, the MiG-21 was a distinctly aging platform. Remember, this is a jet originally drafted with pencils and slide rules back in the 1950s. Yet, there it was, still functioning as a highly lethal air defense shield, successfully executing complex, high-stakes intercepts at the dawn of the 21st century. The ultimate takeaway from the Corey Creek encounter is that tactics, training, and pilot skill dictate the skies. In an air-to-air engagement, the age of the aircraft is really just one variable. A fancy modern radar or high-tech sensor suite means absolutely nothing if you find yourself outmaneuvered by a pilot who intimately knows their machine's limitations. An older, simpler jet flown by a well-trained pilot pushing that airframe to its absolute edge, utilizing solid tactics and ground radar control, is still incredibly dangerous. Finally, Section 4, the enduring MiG legacy. We are finally actually witnessing the extinction of the fishbed in active service right now. Croatia withdrew its fleet in 2024, which closed out its routine operations in Europe. India, historically one of its largest operators, decommissioned its final squadrons in 2025 after more than 6 decades of service, moving over to newer platforms like the Tejas Mk2. And as of early 2026, Cuba is noted as maintaining just 12 active jets. The truth is, these airframes are just incredibly tired. Decades of pulling high G-forces cause microfractures and severe metal fatigue. Without robust factory support for spare parts, the rigorous maintenance demands finally became overwhelming and safety records plummeted. It ultimately forced major air forces to put this absolute workhorse out to pasture. Zooming out, what we're really seeing is a massive philosophical shift in military aviation. It's a definitive shift away from the sheer numbers and raw kinematics that completely defined the MiG-21 toward highly complex, multi-role technology. Today's aerial combat environment is all about beyond visual range engagements. It's about information dominance, right? Jets like the F-35 or the Dassault Rafale prioritize software, stealth, and sensor fusion over sheer speed and maneuverability.
The whole dogfighting era of lightweight, expendable interceptors has been completely replaced by flying supercomputers. So today, the MiG-21 lives on primarily as static displays in aviation museums or kept flying in private heritage collections by dedicated enthusiasts. So, I want to leave you with this thought. Will we ever see a single fighter jet dominate the globe quite like this again? In our current era of incredibly expensive, specialized, and highly classified aerial technology, the idea of producing 11,500 identical, simple supersonic fighters is entirely a relic of the past. The answer is almost certainly no way. The MiG-21 represents a fascinating, truly visceral era of human engineering that is now closed forever. Thank you so much for joining me for this explainer. I hope this helped you understand the